So, hello, thank you very much for inviting us. This is my colleague Arjun Roy. I am Jan Horstmann, and we are presenting joint work with Eirini and Ntoutsi. This work was carried out in the projects Bias and Mammoth, and we're talking about multidimensional discrimination in law and machine learning. So, what do we mean by that? Well, we all have different attributes or categories that we are sorted into, and that is exactly what ML fairness, but also anti-discrimination law are addressing, and what they sometimes want to protect us against, right? And there is a multitude of possible categories that play a role, and the traditional view was to view them as separate, but the starting point of our work was the observation made especially in the late 80s by Kimberly Crenshaw that discrimination happens along more than one axis of social relationships. So these different categories may interact, and Crenshaw pointed that out, especially regarding the marginalization of Black women in anti-discrimination law and policy. This work has then been picked up by legal literature, and interactions of categories have been put into a kind of typology by different authors, for example, Sandra Fredman. And we go into this typology here, starting with intersectional discrimination in a narrow sense, where which affects a group or a person characterized by an intersection of two or more protected grounds. An example are bans of headscarves, which affect Muslim women specifically, not Muslim men and not non-Muslim women. A second type would be cumulative or additive discrimination. Again, the affected group or person is characterized by two protected grounds, but they can at least conceptually be separated. So, for example, hate requirements for security jobs affect both women and people of certain origin, like Japanese, but of course they will most strongly affect Japanese women. Then there is sequential discrimination, sometimes referred to as the classical or simplest case of multidimensional discrimination, where we have repeated discriminatory incidents in a sequence of events, and a person may be disadvantaged based on the same ground again and again, or on different grounds each time. An example would be different discrimination suffered in your work life. So they will, of course, accumulate if it starts with education, then goes on in hiring, and then promotion policies, for example. There is an interesting overlap with cumulative discrimination when you look at multi-stage pipelines, for example, hiring, which can be where we can distinguish and formalize also CV review, assessment center or psychometric tasks, and then interviews, for example. So at each of these stages, we might have, they are in a sequence, and we might have discrimination or disadvantage there. And here again, the disadvantages from the stages can add up and then be accumulated in the final score in such a process. Looking at the law, as this is known in legal literature, one might expect to find a reaction, but the reaction in the law is at least not explicit. We have very little specific statutory provisions in EU law, and little jurisprudence which would operationalize these types of interactions of discrimination grounds in practice. So additive or cumulative and sequential discrimination can usually be dealt with on a case-to-case basis, and here the interaction is not raising great problems, but intersectional discrimination has been demonstrated to sometimes fall between the cracks of these categories that we use to address disadvantage and discrimination. And with these observations, I'll give to Arjun for the ML part.
Thank you, Jan, for the wonderful introduction. In this work, even though we cover or try to formalize or generalize or all the discrimination definitions under an umbrella, but staying to the focus of this work was, which was to identify the challenges and juxtapose with the law counterpart. We in these presentations only look into those two specifics. Starting with the cumulative discrimination case, which is achieved by achieving like discrimination-free decisions with respect to all the protected individual protected attributes, and then somehow combining them with respect to some arbitrary operator. Now, in literature, this has been studied that even though by achieving cumulative discrimination, one may claim to have discrimination-free decision with respect to multiple protected attributes, but sometimes it can run into a problem which is also termed in the literature as fairness gerrymandering, which specifies that like a model which conditioned on certain fairness definition or discrimination free definition may achieve discrimination free predictions with respect to different protected attributes, like in this example such as gender and race, but still may be unfair with respect to some subpopulation of the data, which is also called as subgroups, because like these subpopulations are mainly formed from, or like mainly identified from, the intersections of different groups. Like in this example again, like we see the decision being fair with respect to both gender and race, but like being unfair with respect to some subgroup white females. And yeah, however, like the intersectional discrimination is, even though like is an ideal scenario to achieve, or like intersectional discrimination free decision is an ideal scenario to achieve, uh, to overcome all the challenges such as fairness gerrymandering itself. But in the real world, we see that there is another problem that the ML researchers has to face, and this is the problem of data scarcity, specifically for certain subgroups. Even though like overall adequate data might be available in terms of class distribution as well as group distributions, but distribution or representations of certain subgroups might be still inadequate or very small to train properly a supervised machine learning model. An example, a real world example, as we can see in this slide, is from the adult dataset itself, where we identify one such subgroup called black young females with a very, very less representation and a very class imbalance representation as well. Uh, the challenges in sequential discrimination is bit different, and that's why like in ML literature it has to be identified separately from both cumulative and intersectional case, because sequential discrimination itself starts with the assumptions, then there exists like a sequence of events. So this is of more of a nature of a long term impact. And why this impact is not cumulative, or like is different from cumulative in the ML literature, at least in the sense that if any discriminated decision is received in the previous or in the early stages of the pipeline, or in this sequence, then by ensuring just discrimination free decisions in the later stages of the pipeline won't actually ensure that fair decision or discrimination free decision is achieved in the overall, in the while considering the entire situation itself. So, to overcome that, one has to also study this problem with respect to data which has this sequential information or temporal information with stage-wise information as well. However, in the real world, we still lack certain data, and these kind of studies are mainly dependent on synthetic data generation. This signals also a need for a real-world dataset collections. So in concluding, we see that like intersectional discrimination would be the best thing to achieve, but we still have the problem of data scarcity with respect to certain intersectional groups. This also raises a question like how far one can go in terms of defining like what subpopulation can be considered an individual subgroup itself. Cumulative discriminations, of course, is like the easiest or like the most easy to operationalize definition of discrimination in the ML. However, we see that like it runs into the problem of fairness gerrymandering. So, is there a better way to actually address or like define cumulative discrimination that is like an open case as well? And sequential discrimination, which requires, of course, like a different attention, suffers from the problem of not enough data or no such real world data available to do the study itself. So, we need to collect data as well.
So in the law, we have known this challenge, and I mean that it is a challenge to apply this multidimensionality to make anti-discrimination law deliver for all, especially the most marginalized. And I think this challenge is becoming greater and more important in algorithmic discrimination for some of the reasons in this presentation. And we are still struggling to accommodate, especially intersectional cases. And also the cumulative impact of repeated discrimination over time. Importantly, though, I think for ML and for the law is the multidimensionality of these categories actually highlights normative challenges and assumptions that we may want to call into question. Like, which categories do we need, or do we need categories in our work at all if we really want fairness? And how do we construct them in the law and in computer science? And where are conflicts which may arise between different groups and categories? And we would like to open this debate, and thank you very much for your attention.